together again for the solutions of next worksheet, worksheet 5. This worksheet is about partial fraction decomposition. In the worksheet, you will see that, what is it? Yes, you are now looking at worksheet 5. In this worksheet, what we have 32 questions. And what is my plan? My plan is I will sum 1/4 of these questions. I am planning to solve question 2, question 6, question 10, and question 14. Then I will solve questions 18, 22, 26, and our video will be finished by question 30. So I solved only 8 of 32 questions, but there is remaining how many questions? 24 questions. And for those questions, you are responsible for them. You should try to solve them. If you cannot solve these questions, you can ask me, but we have limited opportunities. To arrange an office hour, we can make something like that. If you are asking me something verbally, without writing anything, if only listening and speaking is enough, we can arrange an office hour in Bilgi Blackboard virtual classroom. But if you need from me to write something, to show something on the paper, we cannot make it on Blackboard Learn page. Instead of it, you can install your computer's Zoom program, and after you install the program Zoom, we can make an office hour arrangement, and you can ask me your questions from that platform. Now I am starting to solving questions. Let's start with question 2. It was r square over r square plus 4 dr. Generally, if we have rational function, first we check degree of polynomial and degree of denominator. If degree of numerator is less than degree of denominator, we can start partial fraction. Otherwise, we need to make polynomial division. So, since degree of polynomial is 2 and degree of denominator is also 2, first we make a polynomial division. When we divide r square by r square plus 4, how many r square plus 4 do we have in r square? It was 1. 1 times r square 4 is r square 4. When we subtract it, r square minus r square is 0. Nothing left, minus 4. So r square will be equal to 1 times r square plus 4 minus 4, which is equal to r square plus 4 minus 4. When we write it here, r square plus 4 minus 4. For the first time, I am writing everything detailedly. In the next question, I may not write everything more detailedly like that. So it will be r square plus 4 over r square plus 4 minus 4 over r square plus 4, which is equal to 1 minus 4 over r square plus 4. So now degree of numerator is 0, degree of denominator is 2. So we are ready for partial fraction, but there is another problem. We cannot factorize r square plus 4. It cannot be factorizable. If we can calculate discriminant of it, which is b square minus 4ac, it will be a negative number, 0 minus 4 times 4, it is minus 16 negative number, so we cannot factorize it. It's irreducible. So we cannot apply partial fraction decomposition in this question. To solve this question, we need another method. Integral of 1 is r minus 4 times integral of this part. Integral of 1 over r square plus 4. I can take this constant for outside of it. Yeah. Next question is, how can we solve this integral? Let's call this integral is I. And we solve this integral, then we replace it, we plug it here. I was equal to integral of 1 over r square plus 4. We can use in this question trigonometric substitution method. I hope you remember it from the last video. What is that? We try to resemble it to tangent, and this is square root of 2. So r is equal to 2 times tangent theta will be a suitable substitution. Then dr will be 2 times secant square theta d theta. After that, we replace everything with theta terms. This integral will be equal to 2 times secant square theta d theta over, instead of r, we are writing 2 tangent theta, and r square will be 4 times tangent square theta plus 4, which is equal to 2 times secant square theta d theta over, in 4 parentheses, tangent square theta plus 1. By the way, tangent square theta plus 1 is equal to secant square theta by a trigonometric identity. So they will cancel. But 4 and 2 are also cancelled. We will have 1 over 2 times d theta. What does it mean? Result is equal to, when we integrate, theta over 2. But we also go back to variable r here. Since r is equal to 2 times tangent theta should be equal to r over 2. So to find theta, we can take arctan of both sides, and theta will be equal to arctan r over 2. So answer will be arctan r over 2 over 2. Now we plug this result in here. So answer will be r minus 4 times this. Minus 4 times something over 2 will be minus 2 times that thing. So r minus 2 times arctan r over 2 plus constant c will be the answer. Now let's start question 6. Question 6 is integral from 0 to 1 x minus 1 over x squared plus 3x plus 2 dx. Now, to take this integral, we need two things. What do we need? First, we are dealing with the integrand. What is that? As a first step, we try to factorize denominator if it is possible. X squared plus 3x plus 2 is equal to 0. When we factorize the last term with 2 and 1, they are add up to 3. So we can write it as x plus 2 times x plus 1. So by making partial fraction, our aim is, instead of this integrand, we want to write it something over x plus 2 plus something over x plus 1. If we can find suitable a and b constants, it will be easy to integrate. So since this equality holds, by synchronizing denominators, we can write this part is a times x plus 1 over x plus 2 times x plus 1 plus b times x plus 2 over x plus 1 times x plus 2. So all of denominators now are equal to each other, so that x minus 1 should be equal to a times x plus 1 plus b times x plus 2. And if we distribute it here, ax plus a plus bx plus 2b, which is equal to a plus b times x plus a plus 2b, should be equal to x minus 1. Then coefficients of x should be equal to each other, and constant numbers should be equal to each other. From here we have two unknown and two equation. A plus b is equal to 1 and a minus 2b is equal to minus 1. If we subtract second equation from first equation, a will cancel each other and we will have 3b is equal to 2, which implies b is equal to 2 over 3. Then if we plug b in a plus b is equal to 1 equation, we will find a is equal to 1 over 3. So that our integral will become from 0 to 1. Instead of this integral, we can divide it by this one. So a times 1 over 3 times 1 over x plus 2 plus 2 over 3 times 1 over x plus 1 dx. And this integral will be 1 over 3 times from 0 to 1 over x plus 2 dx plus 2 over 3 times from 0 to 1 over x plus 1 dx. And then result will be 1 over 3 times integral of 1 over x plus 2 is ln x plus 2 and plus 2 over 3 times ln x plus 1. Then we are evaluating them from 1 to 0. When x is equal to 1, we will have ln 3 over 3 plus 2 times ln 2 over 3 minus we evaluating x at 0, so it is 1 over 3 times ln 2, and when we replace x with 0, minus 2 over 3 times ln 1. But what is ln 1? ln 1 is equal to 0. So this term will be 0, and answer will be ln 3 over 3 plus 2 ln 2 minus 1 ln 2 is 1 ln 2. So it will be ln 2 over 3. So all the answer will be ln 3 plus ln 2 over 3. Now, next question. Question 10. What was this question? Integral of x cubed minus 4x minus 10 over x squared minus x minus 6 dx. Again we need to make polynomial division. If we divided x cubed minus 4x minus 10 by x squared minus x minus 6, we will have how many x squared minus x minus 6 we have in this polynomial? It's degree 3, it's degree 2. So if we multiply it with x, their leading terms will be equivalent. So x cubed minus x squared minus 6x, 6 times x. And when we subtract them, x cubed minus x cubed is 0, minus 4, there will be no x squared here, minus x squared is plus x squared, minus 4x, minus 6x is, as a total, it will be plus 2x, and minus 10. So this integral will be equal to is a whole unit times x plus division is not complete here because degree of remainder is still not less than degree of divisor. So we have 1 times x squared minus x minus 6 here. X squared minus x squared is 0, plus 2x minus x is 3x, minus 10 minus 6 is plus 4. So this integrand will be equal to x plus 1 plus 3x over 4 over x squared minus x minus 6. The algebra we are making with polynomials here are symmetric to that one. In high school or in elementary school, instead of 7 over 5, by dividing it, we can write it as 1 plus 2 over 5. It was the same idea with that, but instead of classical numbers, we are using polynomial. So this integral will be equal to integral of x plus 1 plus 3x plus 4 over x squared minus x minus 6 dx. Integral of x is x squared over 2. Integral of 1 is x. And what about this integral? Let's call this part as integral I. So result will be x squared over 2 plus x plus this integral. Now to solve this integral, first we need to it is in previous question, integral of 3x plus 4 over x squared minus x minus 6 dx. We need to make partial fraction decomposition. As a first step, we should factorize this one. X squared minus x minus 6 can be factorized. Minus 6 can be factorized either minus 2 times 3 or 2 times minus 3, whose add up to minus 1, this one. So this is equal to x plus 2 times x minus 3. So that we can decompose this rational function as something over x plus 2 plus something over x minus 3. Then let's synchronize the denominators. We will have 3x plus 4 should be equal to 8 times x minus 3 plus b times x plus 2. After that, in previous questions, we distribute a and b, and we find, after adding terms, we find another polynomial here, and we send coefficients of same power of x should be equal to each other. Now, since they are similar, let's this time use another method. This equality is holds for each value of x, but in particular, if we choose some special values, we will have different equations, and it may be beneficial for us. For example, if we choose x is equal to 3, this equation should be again valid. When x is equal to 3, 3x plus 4 will be 13, but I choose x is equal to 3 because I want to vanish one of these terms. When x is equal to 3, this factor will be 0, so it will be a times 0, and there will be no a here, plus when x is equal to 3, this part will be 5b. So 13 is equal to 5b, which means b is equal to 13 over 5. Also, if x is equal to 2, if x is equal to minus 2, this time this term will vanish. When x is equal to minus 2 times 3 plus 4 is equal to minus 2 is equal to 8 times minus 2 minus 3 is minus 5. So 8 times minus 5 is equal to minus 2. Then a should be 2 over 5. So this part will be 2 times x over 2 plus 2 over 5 over x plus 2 plus 13 over 5 times 1 over x minus 3. So integral will become 2 over 5 times integral 1 over x plus 2 plus 13 over 5 times 1 over x minus 3. Hence, when we take their integral, we will have 2 over 5 times ln x plus 2 plus 13 over 5 times ln x minus 3. Then we plug in them in their places. We had find integral of x plus 1 plus this rational function is x squared over 2 plus x. Now instead of I, we are replacing it with this result. So it will be x squared over 2 plus x plus 2 over 5 times ln x plus 2 plus 13 over 5 times ln x minus 3 and plus a constant. Since it's an indefinite integral, this was the result. Now question 14. Here's question 14. X squared over x minus 3 times square x minus 3 times x plus 2 square dx. So again, first we decompose the integral. By the way, degree of numerator is 2, degree of denominator is 1. 2, 1 plus 2 is 3. So we don't need polynomial division in this stage. Hence, let's write x squared over x minus 3 times x plus 2 square is equal to a over x minus 3. Be careful about here. We have x plus 2 square. When we have a power of a primitive irreducible polynomial, while making its partial fraction, we starting adding up constant over that polynomial from power 1 to that power. So we will have both b over x plus 2 and c over x plus 2 square. Then, to synchronize denominators, we should expand first rational number with x plus 2 square, second one with x plus 2 times x minus 3, and for the last one, we should expand it with x minus 3. After synchronizing, we have x squared should be equal to a times x plus 2 square plus b times x plus 2 times x minus 3 and plus c times x minus 3. Uh, then we should determine the constants a, b, and c. For example, to vanish a and b, we can look at the particular case x is equal to minus 2. If x is equal to minus 2, x squared will be 4. And when we replace x with minus 2, this vanish, this term vanish. Only we have minus 5 times c. Also, to vanish x minus 3, we can choose x is equal to 3. When x is equal to 3, we will have 9 is equal to x plus 2 square will be 25, 25a, and these terms will be vanish. So we can find a and c from here. To find b, we can let another value for x, but none of these terms will cancel. But to make calculations easier, between minus 2 and plus 3, we can choose plus or minus 1. Let's choose x is equal to minus 1. Then x squared is equal to plus 1. A times x minus 1 square is, we replace x with minus 1. So it will be plus 1a. 1 times minus 4. So minus 4b and minus 4c. So what do we have here? From first equation, c is equal to minus 4 over 5. A is equal to 9 over 25. And from the third equation, if we replace them their place, in 4 parentheses, or 4b plus 4c, first take this one to left hand side and this one the other side. A was 9 over 25 minus 1, which is equal to minus 16 over 25, and this part will be 4 in 4 parentheses b plus c. Then if we divide both sides by 4, we will have b plus c is equal to minus 4 over 25. But we had already know c was minus 4 over 5. If we expand it by 5, it will be minus 20 over 25. So b minus 20 over 25 is equal to minus 4 over 25. And from here, b will be 16 over 25. So we determine A, B, and C. Now by replacing them, let me write integral again. Integral of x squared over x minus 3 times x plus 2 squared dx can be equal to, what was a 9 over 25, 9 over 25 times integral 1 over x minus 3 plus b times, what was b? 16 over 25 times 1 over x plus 2 dx plus, what was c? Minus 4 over 5 times integral of 1 over x plus 2 square dx. Then this will be equal to 9 over 25 times integral of 1 over x minus 3 is ln x minus 3 plus 16 over 25 times this integral will be equal to ln x plus 2, and for the last one we have minus 4 over 5 times integral. We can write this one as x plus 2 to the power of minus 2 dx, so that this integral will be, we increase its power by 1, x plus 2 to the minus 1 over new power, which will be minus 1 over x plus 2. So result will be 9 over 25 times ln x minus 3 plus 16 over 25 times ln x plus 2, and minus 4 over 5 times this will be plus 4 over 5 times x plus 2 plus constant c. Question 22. That was x squared minus 2x minus 1 over x minus 1 squared times x squared plus 1 dx. First, this is a rational function. Denominator is already factorized. Degree of denominator is square of the polynomial degree 1 and is polynomial of degree 2 add up to degree 4. And degree of numerator is degree 2. So we don't need polynomial division. X squared minus 2x minus 1 will be decomposed to factors of its denominators. First factor is x minus 1, but it has square. So in the decomposition, we will have all powers of x minus 1 starting from 1 up to its actual power in the denominator, which is 2. And plus the other decomposing part is x squared plus 1. By the way, x squared plus 1 is irreducible. We cannot factorize it anymore. So it will be as a polynomial with degree 2. Then, since x minus 1 is degree 1, nominators here will be only constant numbers. But since x squared plus 1 is degree 2, nominator should be a general polynomial with degree 1. So it will be cx plus 4. Now, we decompose it. Before the decomposition, we should synchronize the denominators to make denominator of everything x minus 1 square plus times x square plus 1. We need to expand first term with x minus 1 times x square plus 1, so that multiplication of expanding both numerator and denominator will give us this denominator. Similarly, for the second term, we already have x minus 1 square. What is missing here? X square plus 1. And here, x square plus 1 is okay, but x minus 1 square is missing. Then, x square minus 2x minus 1 is equal to a times x minus 1 times x square plus 1 plus b times x square plus 1 plus x minus 1 square times cx plus d. This is our general equation, and this is true for each value of x. Like was previous question, to vanish some terms, it will be wise to replace x with 1, so that x minus 1s will be vanished. Only information about b will remain. When x is equal to 1, x squared minus 2x minus 1 will be 1 minus 2 minus 1 minus 2. This vanish, this term vanish, but this term will be 2b. So from here we can deduct b is equal to minus 1. What is next? X squared plus 1 don't have a root. So we cannot, by letting a value to x, we cannot vanish any of these terms. But instead of it, we are finding some equations, and it will be easy to use small numbers such as 0. When x is equal to 0, we can quickly calculate left-hand side. It is minus 1. This part plus 1, minus 1, minus a, plus 1, b. This is minus 1 square is plus 1. Also d. This part will be d. Also we have b is equal to minus 1. When we replace b is equal to minus 1, we will have minus 1 is equal to minus a plus minus 1 b plus d. So that we can cancel this -1, take -a to left hand side, and we can find that a is equal to d. So we can continue. We let x is equal to 1, x is equal to 0. Let this time say x is equal to -1. Then when x is equal to -1, x square minus 2x minus 1 will be +1, +2, 3, -1 will be equal to 2. Is equal to, since x is equal to -1, this part will be 2. This part will be -2, -4. It is -4a -1 plus 2b, and 4 times, since x is equal to -1, this will be d minus c. So that, what do we have here? 2 is equal to, this 2b will be -2 since b is equal to -1. And we can take this -2 to left hand side. 4 is equal to -4a plus 4d minus 4c. But also we have found that a is equal to d. So instead of this d, we can write a, and -4a and plus 4a will cancel each other. So we can find 4 is equal to -4c, which implies c is equal to -1. So that we find b and c is equal to -1. What is next? Determining d. To determine d, let's x is equal to 3. Then when we let x is equal to 3, 3 square minus 2x minus 1 will be 2. And x square plus 1 will be 10. X minus 1 will be 2. So we will have 20a plus 10b plus 4 times 3c plus d. But we already know the value of b and c. They are -1. So when we replace them their place, 2 is equal to 20a minus 10 minus 4 times 3 is -12 plus 4d. But d was equal to a, so it is plus 4a. At the end, we can find 24a is equal to, we can take these scalar numbers to left hand side, 24. So when we cancel them, a will be equal to 1. And since d is equal to a, d also will be equal to 1. So that we complete the decomposition. X square minus 2x minus 1 over x minus 1 square plus x square plus 1 is equal to what? 1 over x minus 1 minus 1 over x minus 1 square, or plus minus 1, plus minus x plus 1 times over x square plus 1. Now, what will be next? Now we had decomposed it. Now we are ready to integrate. Integral of 1 over x minus 1 plus minus 1 over. When we have x minus 1 square in the denominator, we can write it as a power form like that. Plus minus x over x square plus 1 plus dx. So integration of 1 over x minus 1 is easy. It is ln x minus 1. Integration of x minus 1 to the power of minus 2 is, when we increase its power by 1, it will be x minus 1 to the minus 1. We also divide it by minus 1, but we have also another minus 1 here, and they will cancel, plus this integral. I don't directly write this integral because maybe it has some operations to need. Here we have again a rational function. In the denominator we have a polynomial with degree 2 and in the numerator degree 1. So it is possible to make resemble numerator to denominator. What is derivative of x squared plus 1? 2x. So I want to resemble numerator to that. How can I do that? First I separate it, minus 2x over x squared plus 1 dx plus 1 over x squared plus 1 dx. And this integral is, we know, arctan x. For this integral, we need in the numerator 2x, but we have minus 2. So if we multiply and divide it by minus 2, in the denominator we will have plus 2x. So this integral will be minus 1 over 2 times 2x over x squared plus 1 dx, which is equal to, since numerator is exactly derivative of denominator, it's equal to ln denominator times minus 1 over 2. So when we plug everything in the answer will be ln x minus 1 plus 1 over x minus 1. I wrote this, and this integral minus 1 over 2 times ln x squared plus 1 plus arctan x plus constant c. So this was the answer of the question 22. Next question is question 26. Where is that? It is integral of x over x squared plus 4x plus 13 dx. It is very different from the previous questions because degree of numerator is less than degree of denominator, everything is okay, but to apply here partial fraction, we need to factorize x squared plus 4x plus 13. Can it be factorizable? To check it, we can look at discriminant is positive or negative, which is b square minus 4ac. What is b? B is coefficient of x, it is 4. What is a? Coefficient of x squared. What is c? Constant number. So it is equal to 16 minus 52. So it is minus 36. It's a negative number. So this polynomial is irreducible. What does it mean? We cannot factorize it. So we cannot solve it by using partial fraction decomposition. What can we do? Maybe we can make trigonometric substitution. But trigonometric substitutions was in the form, if we have expression in the integrand, something square plus or minus some constant numbers. Or this part will be plus or minus. If question was in that form, we can make it. But if we have only x squared plus 13, that was okay. But also there will be 4x here. So to solve this problem, we adapt to this x plus something square. I mean, instead of x squared plus 4x plus 13, I try to write x plus some number a square plus another number. I try to write it in that form. After that, it will be resemble to making trigonometric substitution forms. So for the perfect square, it started with x square. X plus a square is actually x square plus 2ax plus a square. So coefficient of x is 2a. So 2 multiple of a is 4. So I will choose a 2. I mean, I will choose, if a is equal to 2, it will be x squared plus 4x plus 4. So let's write it x squared plus 4x plus 4, but they are not equal. What is left here? Plus 9. If I add here also plus 9, they will equal. So instead of this number, I can write x plus 2 square plus 9. So it will be good to make substitution. Instead of x plus 2, we can write c times 3 times tangent theta. We can make this trigonometric substitution. Then, what is dx d theta when we take derivative of it? Every time when we make substitution, we always take its derivative and calculate dx and d theta to use in the integral. Dx is equal to 3 times derivative of tangent theta is secant square theta times d theta. And our integral was x was 3 tangent theta minus 2, dx was 3 times secant square theta d theta over x squared plus 4x plus 13, which is, sorry, x plus 2 square plus 3 square is, x plus 2 is 3 tangent theta, so all of them will be 9 tangent square theta times, what is that, 9. Then our integral will be equal to This 9 tangent square plus 9 in 9 parentheses will be tangent square plus 1, which is equal to 9 times secant square theta. So this integral will be 3 times tangent theta minus 2 times 3 times secant square theta d theta over 9 times secant square theta. What is next? Secant squares will cancel. This 3 and 9 will cancel. So we will have integral of 3 tangent theta minus 2 over 3 d theta. And what is next? When we integrate this one, before integrating, let's separate it to parts. Tangent theta d theta minus 2 over 3 d theta. What is integral of tangent theta? Maybe if you know, you can directly write the result. Otherwise, you can consider this one sine theta over cosine theta d theta, and you can observe that numerator is not a derivative of cosine theta, but we need minus, so we can multiply it 2 times with minus, nothing will change. Now, numerator is derivative of denominator, so this integral will be ln denominator, ln cosine theta, but we will also have minus here. So answer is minus ln cosine theta. What is next? Minus 2 over 3 theta is minus 2 theta over 3, but we also have another minus will become plus. So result will be this. But answer is, in terms of theta, we need to go back to x again. What was our substitution? We had said x plus 2 is equal to 3 times tangent theta. If we divide every part with 3, we can find tangent theta is equal to x plus 2 over 3. If tangent theta is equal to x plus 2 over 3, then we can draw a triangle. If this angle theta, since this is x plus 2 over 3, length of this side is x plus 2, this side is 3, and we can calculate by Pythagoras theorem length of hypotenuse is square root of adding up squares of this one, which is equal to x squared plus 4x plus 13. So what is cosine theta? 3 over x squared plus 4x plus 4. So minus ln 3 over square root of x squared plus 4x plus 13 plus 2 over 3 times theta. If tangent theta is equal to x plus 2 over 3, what is theta? Taking arctan of both sides, and it will be arctan x plus 2 over 3 plus a constant c. Was the answer. Or since there is negative sign on ln, we can take this minus 1 inside of ln to the power of minus 1. So it will be ln square root of x squared plus 4x plus 13 over 3 plus 2 over 3 times arctan x plus 2 over 3 plus a constant c. Now question 26, answer of question 26 is that, and we are ready for the question 30. Question 30 is 2x cubed integral between 0 and 1, 2x cubed plus 5x over x to the 4 plus 5x squared plus 4 dx. So degree of numerator is 3, but degree of denominator is 4. So we are ready to decomposing. So for its first step, we need to factorize denominator. Can we factorize a polynomial of degree 4? They are not easy problems, but only for these questions, by observing something, we can succeed to factorize it. We have x to the 4 plus 5x squared plus 4. We want to factorize it. And we are lucky that there will be no x cubed or x. All of variables including x is even variables. So instead of x squared, if we use t, we can write x to the 4 as t squared. So this polynomial will become t squared plus 5t plus 4. And we can factorize this polynomial as t plus 4 times t plus 1. So that its factorization will become, replace t with x squared again, x squared plus 4 times x squared plus 1. And likewise previous question, by checking their discriminant, we can see that they are irreducible polynomials. We cannot factorize it anymore. So we try to write this number in that form, something over x squared plus 4 plus something over x squared plus 1. But since these polynomials are degree 2, in the denominators, there won't be only scalar numbers, but they will be general polynomial of degree 1. So something times x plus constant number and something times x plus constant number. We decompose it like this way. Then after synchronizing first denominator by x squared plus 1, second denominator by x squared plus 4, we will see that 2x cubed plus 5x should be equal to x squared plus 1 times ax plus b plus x squared plus 4 times cx plus d. Then we let some value for x, so that we will find result. But I think this method is not good for this question. Maybe we can distribute them over parentheses, will be more easy to calculate. I'm not sure, but let's make like that. X squared times ax plus b will be a times x cubed plus bx squared. Now we distribute 1 plus ax plus b. Now distribute x squared over here. C times x squared times x is x cubed. 4 times x squared is 4x squared. Now distribute 4. 4cx plus 16. And what is that? First, collect all the terms including x cubed. They are a plus c x cubed. Now collect all terms including x squared. It is b plus 4x squared. Then collect all terms including x. It is a plus 4cx. Lastly, write constant numbers b plus 16. They should be equal to 2x cubed plus 5x. Then in this equation, coefficients of same power of x should be equal. So coefficient of x cubed in left hand side is 2, in right hand side is a plus c. There is no x square here, so coefficient of x square is 0. So b plus 4 should be 0. By the way, which implies b is equal to minus 4. What is next? Coefficient of x is equal to 5. So coefficient of x is equal to a plus 4c. Last one, there is no constant number 0, but here constant number is 16. It is impossible. That means I make a mistake here. Okay, I find my error. What is that? It is here x squared plus 4 times cx plus 4. I wrote mistakenly, but that should be cx plus d. This should be not 4, but d. So when we multiply here, some things will change. What is change? It will be cx cubed 4x square, and this should be d instead of 4, and also this should be 4d. So what will be changed here? This should be d, and this should be 4d. So we will take coefficients again. Coefficients of x cubed is in the left hand side 2, in the right hand side a plus c. Coefficient of x square in left hand side, there is no x square, so it is 0. In the right hand side, it is b plus d. Coefficient of x in the left hand side is 5. In the right hand side, a plus 4c. Coefficient of x to the 0, constant numbers, not exist in left hand side, but 4d in the right hand side. So from last equation, we can find d is equal to 0. Let's write d is equal to 0. So from second equation, we can find b is equal to 0. What is remaining? A plus c is equal to 2, and a plus 4c is equal to 5. If we subtract first equation from second equation, we will have 3c is equal to 3. So c will be equal to 1. When we replace c is equal to 1 here, we will find a is also equal to 1. What does it mean? Our integral will become from 0 to 1 ax plus b, which is equal to a is equal to 1, b is equal to 0. So x over x squared plus 4 plus from 0 to 1 cx plus d is again c is 1, d is 0, x over x squared plus 1 dx. And again, degree of numerator is 1 and degree of denominators are 2. So to make resemble nominators to do derivative of denominator, we can multiply and divide each integral by 2. So that first integral is 1 over 2 times, result of this integral is ln denominator, plus 1 over 2 times, this integral is ln x squared plus 1. And we are evaluating them between 1 and 0. What is that? When we evaluate it by x is equal to 1, we will have 1 over 2 times ln 5 plus 1 over 2 times ln 2 minus 1 over 2 times, when we let x is equal to 0, it will be ln 4. ln 4 is equal to ln 2 square, which is equal to 2 ln 2 plus 1 over 2 times ln 1. What is ln 1? E to the what is equal to 1? Always 0. So answer will be 1 over 2 ln 5 plus 1 over 2 ln 2. 2 ln 2 times 1 over 2 is 1 ln 2 minus 1 ln 2. 1 over 2 ln 2 minus 1 ln 2 is minus 1 over 2 ln 2. So in 1 over 2 parentheses, ln 5 minus ln 2 will be the answer of the last question. By solving this question, we complete this video. See you in the next videos. If there is something you want to ask about these questions or about other questions in the worksheet, we can make an office hour with an application Zoom if you want me to write something on paper, or if your question can be solved by only speaking and listening, we can arrange it on the Blackboard Learn. It's up to you. So see you until the next video.